I have completed it. The basic idea is that when a car is parked and it starts moving forward, who pushes the car? You know the answer, I suppose. Friction. Which friction? Which friction? Static friction. Correct. Okay, so that's one motion taking place here. And speed is increasing. As friction pushes more and more and more, speed of the car is increasing here. But now car is not only going straight but is bending. And when car bends, then radial force is also required. Radial force, which is along the width of the tire. Right? One force is along the length of the tire, other force is along width of the tire. Now, who provides that centripetal force? Which type of friction? Again, static friction, right? So when a car is moving in circular path, then there are two components of static friction. It's a very interesting situation, two components. One component pushes the car forward, one component provides the centripetal force. That's exactly what is shown in the figure. One component is providing tangential acceleration, other component is providing the radial acceleration. Net frictional force, static frictional force, is in this direction. So we want at what speed will it skid. That means static friction has done its best and is just giving up, limiting case. That's why we took F equal to mu n, because it's limiting case. Vertically only mg is there and normal reaction, so n is equal to mg. Let me know if you have any questions here. More than one option may be correct. You can refer to the previous board. It is just like that, and try to select all the possible answers, correct answers. Let's go one by one. How about option A? You can just select tick or cross, right or wrong, that's it, for option A. That's right. Option A is wrong. Answer is right, option is wrong. Just like this figure, net acceleration won't be towards the center. Option B, just select right or wrong. Pick or cross, I mean. Magnitude of frictional force is greater than the mv square by r. Let's see. Small f. Yes, in fact, one component of F is mv square by r. F has two components. One component is mv square by r, and other component is now if I use vector notation, then radial vector is outside, so technically I should put a minus sign. So F square will be this square plus this square. It has to be bigger than mv square by r. D has to be correct. Any questions about D? Let me know. How about C? Friction coefficient not less than A by G. Let's go to that board. Friction coefficient. So mu square is written here. Mu square is v to the power 4 by g square r square plus a square by g square. Okay. That means it is v square by gr square whole square plus a by g whole square. Yes, it has to be more than a by g. This number is positive number, v square by gr square. Option C, not less than. Yes, it is not less than, it can be more, but not less than a by g. Let me know if there is any question about option C. How about option D? It has to be wrong. You are right, it has to be wrong, because where is tan coming anywhere? Mu square is this square plus that square. Where is tan? And if one wants to get 10, and if one divides these two, look at the pointer, if one divides these two, then small f is gone. And if small f is gone, mu won't come. So D is not correct. B and C. This symbol means not greater than. This means not less than. Only one option is correct. I have put up the 4 options for you. A, B, C, D, you can see. They must have appeared here on this line. Water does not fall. Topmost position is the most dangerous position. Inverted at the top. Bucket is inverted at the top and water doesn't fall. That means if we take water as our system, our system boundary will be very close to this borderline. Let me try to draw the system boundary. Okay, that's the system boundary. Water alone in the system. Now water will get gravitational pull by earth. So water system has gravitational force mg and bucket has its walls, so normal reaction. Normal reaction may be somewhat complicated, but due to the argument of symmetry, we can say it would be more or less downwards. Otherwise, different walls will exert normal reaction. Then, is there anything else? Nothing. So, mg plus n should be mv square by r. That means mg is mv square by r minus n. Mg cannot be more than mv square by r. If n is 0, just limiting case. If n is 0, then it can be equal to it, or it can be less than that, not more than. C. Any questions? Let me know. Proceeding further. This type of analysis is very important. Cycle or motorcycle on some overbridge. gravitational down, normal reaction, you need the centripetal force towards the center. Net force should be towards the center. Now why net force towards the center? Because driver maintains a constant speed. That means friction should not accelerate. Friction should not accelerate. But then gravity has a component which will slow it down. Now friction should not let it decrease also then. Gravity is trying to slow it down. Gravity has component here, right? That means friction should balance it. So friction should act in this direction. Just to compensate for gravity. So mgn. mg has a component here. In this direction you don't want speed change, so that component balanced by this. Another component of mg will be in this direction. So mg broken into two pieces. This component of mg minus n, that's what should be providing the centripetal force. mg, now mg into something, mv square by r. So n is mg into something minus mv square by r. R is fixed. Question says constant speed. So v is fixed. Mass is of course fixed. Only thing which will change n is this bracket. M is fixed, G is fixed. This bracket. What is that bracket? So for that, let us extend this. So first let us define theta. Let us call this theta. Then it would be cos theta. So now we can say mg cos theta. Clearly, it all depends on theta. If one is ascending, then what should happen to theta? If one is ascending, what should happen to theta? Theta should decrease. Theta should decrease. And cos is which type of function? Cos is increasing function or decreasing function? Cos rises or cos falls? Cos falls. Cos is a decreasing function in the first quadrant. So if theta is decreasing, then it means cos should increase, isn't it? If theta is decreasing, then cos should increase. Yes, the answer is option A. If you have any questions here, then let me know. more than one options may be correct. Well, uniform circular motion if you want, then net force should be towards the center, net force. There is no foundation on individual forces. So what's wrong with applying vector F force? Who cares about individual forces? The requirement is that net force should be towards the center, and that should be mv square by r. That's it. So option A is not correct. For example, suppose this force is acting on the particle wherever it goes. Well, we can cancel it by applying another force. And then we can have a third force like this. So there are other forces on this particle. Well, if we show only F, how is it going to be possible? Net force changes direction, right? Net force changes direction as the particle goes round and round. Single direction force can never provide centripetal force forever. Single direction force can never provide it. So there must be other forces. The resultant of other forces is mv square by r? No. Resultant of all forces should be mv square by r. All forces. So not other, but all forces. This, whoever is present. The resultant of other forces varies in magnitude as well as in direction. Resultant of other forces must vary, because if I try to balance F by this F, then I will have to keep on changing this here, no other choice. So the resultant of other forces will have to change. Now, what I was thinking was about this magnitude point. The resultant of other forces must change in direction. That's very much understandable. Why should it change in magnitude? Any idea? Suppose in this figure, we are saying that we will apply another force F, which will cancel this force, and then we will apply some force which will always be towards the center, whose magnitude will be mv square by r, right? So two more forces we will apply. so that net of these three will always be mv square by r. Okay, suppose we take this example. Then the resultant of other forces, resultant of these two forces will change in direction, because mv square by r will change in direction. But how about this point? Why should the magnitude change? And the answer is magnitude should change because the angle between them is changing. Say for example, some point here. Now what will happen? mv square by r will be like this, where one f will be this, other f will be this. As far as other forces are concerned, this f and this mv square by r. This angle has changed. It is different from this. Now you understand why the magnitude will also change. D is correct. So B and D. More than one options may be correct. You don't have to answer here. We stop at this point.